So Brian already introduced me. My name is Michael Schmid. I'm responsible for production for CPUs and APUs in AMD EMEA. That means the classic CPUs, and most of you might have heard about the APUs. That's a collaboration between graphics and CPU cores in one chip. This will be in the future also very interesting for high performance workloads. But I will skip this time in the presentations because there are not too much applications, or we're not from the hardware side ready to have these workloads there. So therefore, I will give an update about our OPTERON strategy and what we introduced last year, why it's important, and what we're going to introduce next. But the next is just a snapshot. So this is our general OPTERON strategy, which is maybe for the first look a little bit complicated, but it's actually very easy to understand. So we've got three market segments. That's a 4P and 8P. That's usually your market, the 2P platforms and 1P platforms for low cost and web and hosting. So in this presentation, we concentrate on the first two ones. And we've got two series of CPUs in there. That's the OPTERON 6000 series and the 4000 series. The 6000 series is the top one. So this one is really targeted for performance per watt, and the 4000 series is more targeted on highly efficiency and cost optimized. So therefore, the 6000 series might be the more interesting CPU type from you. And we introduced 2 years ago the 6100 that has a huge installed base already, especially in the high performance computing sector. And we just introduced last year the 6200 series. That's a complete new core. The codename was BULLDOZER. Most of you might have heard of that. And we will introduce future product, let's say, pretty soon. The really interesting part is with all the generations, you don't have to worry what's inside the CPU because it's still the same chipset, same infrastructure, same software, same APIs, same compilers, everything. So even if we have introduced a complete new core, it fits into the same infrastructure, hardware and software-wise. As you can see, HPC computing, big topic for AMD. The design of the 6000 series was really for high-performance HPC clusters. And this, I will go into the features a little bit later, but this is really where we targeted this CPU. Like I mentioned already, we've got the generations, so same APIs, same BIOS, same drivers for the whole platform. But nevertheless, we've got all the same features in the CPUs. Our competitor sometimes depends on the price what you pay for a CPU. You get special features, so more memory bandwidth or more memory channels or higher frequencies. We don't do that at AMD. So if you buy a CPU, 6000 series, this will have the memory channels all the same. Doesn't matter which part of the stack you buy. We'll have the memory speed the same. So we won't get any penalty on the CPU. In addition to that, the 6000 series fits into the 2-socket systems and 4-socket systems. So if you start running a cluster, you can start with a 4P server equipped with 2 CPUs, can add CPUs as you want, so you can mix and match them as you're really demanding the performance. This gives us 3 advantages at AMD. So if you bought an AMD server, or one of our partners, because we don't do the servers, so an HP or an Asus server, you can easily add servers because they have the same infrastructure. So it's easy to buy, easy to qualify, and easy to manage. So it's got one infrastructure, and it doesn't matter if you add to a 6000 series server farm, some 4000 series server, because you need them for special workloads. Doesn't matter. It's compatible through the whole stack. Let's talk a little bit about BULLDOZER, the CPU we introduced last year, and the features. So, of course, every time we introduce a CPU, we want to have more performance out of the same infrastructure. So we say it's a 71% improvement when you add up all the things. So we have more cores. In this case, it's the world's first 16-core processor, x86, I have to say. We've got a boost. I will come back to that later. It's called turbo core. So you can increase really the performance if you need it for a certain time frame. Multi-threaded floating point unit. This is a unique feature of BULLDOZER. From the new generation, I have a slide on that as well. And of course, we added some new instructions. Greater efficiency. So that's the lowest watt per core, per physical core, I have to say. And we support ultra-low voltage DIMMs. And we have a feature that's called TDP power capping that might not be so interesting for you. This is for mainly for data centers that are running out of space or power capacity and cooling capacity. So there's this $1 million server. This is the server you buy, and then you have to build a new data center actually to host this server. And with TDP power cap, you can reduce the power in 1 watt levels from the service that you can maximize the space in your data center. FLEXFP, I think that's the most interesting topic for this audience because with the new design, we have some dedicated resources in the CPU. That's the integer cores. And we've got shared resources on the chip level, which are all the scheduler, the L2 cache. L3 cache is shared on the CPU level. So this is just one BULLDOZER module, and we call it module because we had some interesting conversations going on with software partners if this is still defined as a core, and in the end decided, yes, it is, but actually that's already a dual core. So with the shared resources, like the floating point unit, which is red here, you can run simultaneously SSE instructions, AVX instructions, so you don't have to any waiting time. They can run it really simultaneously. Then you've got the 180-bit AVX or SSE instructions, but then you have to recompile the software. You can combine the two floating points units and have it as a 256 instruction, as a 256 floating point unit. And of course, we added more instructions like FMA4 and XOP instructions, and this means you need fewer cycles with AMD than with the competition to actually run your software. And it has a dedicated floating point scheduler. We have it here, which is responsible for bringing the data into the floating point unit. And with that, you've got no waiting for integer scheduler because they're independent for the integer cores and will be always available to do the floating point operations there. So very clever design. This design really was built from the scratch. So our engineers took a white paper, said, okay, what do we need in the CPU? What do we have to share? What do we have to have dedicated? And this is the result of it. And I think it's a very clever design, especially with the flexibility they built in the floating point unit, and of course, with the efficiency of the core itself. Let's go on a CPU level. I think all of you know our hypertransport architecture. In the old time, we didn't have that crossbar here. So actually, with the CPU 0 wants something from CPU 3, it had to add one hop more. So we increased that architecture with adding the two connections, and as well we had add more memory channels to the chip. And therefore, if you need data from one CPU, it's just one hop. Doesn't matter where the data is stored. So this is also a big improvement and saves a lot of time. This means also the memory controller inside the CPU was totally redesigned, and that means we've got the 33% more memory throughput and the 71% more processing power when you compare it really on the chip level then. But like I said, the memory controller was redesigned with the CPU, so we can get more memory there, faster memory, and with higher frequencies. One thing that is also unique to AMD, let's start on the right side. So if our competition talks about cores, they mainly talk about threads. They have a technology called hyperthreading, which means that they can tell the operating system that a thread is not bundled to the core anymore. So we took, in this example, 16 threads for the OPTERON and 16 threads for the Xeon processor, which means the OPTERON processor with 16 threads has 16 physical cores. When Intel talks about cores, and they have most of them 12 cores, that means that you have to go and execute on 6 cores, on 6 physical cores. This is not so bad if you have workloads that are not fully utilizing the CPU, like for virtualization, where the server utilization is by 50, 40, 60%. But if you imagine, it's like a highway. If there's less traffic, it works fine. Then you got a construction zone, and everybody knows when they merge the lanes, and you've got lots of traffic, it's traffic jam. We don't have that construction zone here. 16 threads means 16 cores. So we always talk about physical cores. I mentioned this already a little bit. That's our turbo core technology. I have to be honest, our competition has something similar as well. That means the CPU really looks what workload do I have to do. Am I normal utilized? That means it's inside a normal workload, normal TDP. The highest TDP we have, so thermal design power is 140 watts per CPU. So it normally stays in that range and says it draws then maybe 195 watts, something like that. So there's still some potential that the CPU can clock higher if it needs to. So let's say we put 16 threads on one CPU. Then it says, okay, I still have got some potential. I've got 35 watt left I can utilize. So I am going to higher my frequency on our cores to get the workload done quicker. And then, of course, go back to idle earlier. But this, actually, to be honest, is really not an all-time standard. Because if the CPU runs hot, it does not go beyond the specification, but it say, okay, if I come to the border of the specification, I've got my 140 watt, and the workload is still not done, and it's getting dangerous, then it will throttle back. And actually, to get it as fast as done as possible, but you cannot have the turbo enabled all the time. But if you have, for instance, a software that's a little bit older, or you only have 8 threads, so half of the CPU is utilized, then it shuts down the other 8 cores, actually takes that thermal budget and puts it to the other cores and boosts the rest of the cores up to 1 gigahertz. So when you have single-threaded or not so multi-threaded application, you can really boost frequency. If the application is frequency depending, then it really gets very fast. Also, this power state is not for all-day use, but it depends on your infrastructure you have in the data center. It really can run for several hours in the turbo motors. That means all-core boost when you have really multi-threaded software, max boost if you just utilize half of the cores. So it's really depending on the software, but you can really execute your software faster with that feature. And that feature is inside AMD specification. So we guarantee you, because sometimes it's overclocking, the people say, as long as you use the normal turbo mode, we guarantee you the CPU will run smoothly, and if there's any problem, we're going to exchange it. This is inside the specification, not overclocking. Very important. I have to speed up a little bit. I've got 5 minutes left. So quickly, new features. I already said, okay, optimization on the module. We build it from scratch. We've got new instructions, and I have a list on the last slide. Virtualization is not so important for you, but really, we call this bulldozer technology because this was really a big step forward for AMD. And performance of monitoring, I said already, the CPU is very intelligent, so it really boosts or sleeps as the software is demanding it. Let's go a little bit into the instructions, and I think this list is very useful for you, so maybe we can distribute it afterwards with the presentation, because this tells you what is an AMD unique instruction, what is an AMD and Intel instruction, and of course we skipped the Intel unique instructions, so you have to read that on the web page from Intel. But as you can see, most of the instructions are similar, and some customers are really a little bit worried, so they come to us and say, is my software running on AMD? Say, yes. Are you running your software in 64-bit? They might say, yes. 64-bit is an AMD technology. We invented it. And it's part of the cross-licensing agreement with Intel. They give us the x86 architecture. We give them 64-bit. So even if you buy an Intel CPU, there is AMD technology inside. And as you can see on the list, of course, the two companies are talking together actually to make the software compatible for all users, because it doesn't make any sense to push somebody out of the market. We both need competition, because with competition we still keep innovating and adding new features, and there's some pressure in the market, and I think both companies need that, because otherwise our engineers are getting lazy, I guess. And the same is for Intel. Quick a summarization of everything we put into. As you can see, we've got great performance, and this is some benchmark data. We hope we get the new benchmark data for the new Intel CPUs pretty soon, so that we can update these slides. And like I said, the density is really very flexible, and we say almost twice the flops per square feet with an AMD OPTERON series. This is really when you do physical cores. Otherwise, you have to have hyperthreading for virtualization for these workloads. But especially for high-performance computing, you will get double the density that you will get with the competition.